In section 13.2, we start dealing with some angles that are on the XY coordinate graph. So the section is angles of rotation, but we did reference angles, angles of rotation, coterminal angles, and then using a point to find the terminal angle and finding the 6 trig functions. So the first one that I chose, number 30, find the measure of a positive angle and a negative that are coterminal with 254 degrees. So I'm going to begin by just sketching 254 degrees. It doesn't have to be exact, we're just trying to get an idea of where it would be. Over here we start with 0. It is a positive, so anytime it's positive we're going to go up from the x-axis, from the positive x-axis, and each time we go a quarter of the way around, that is 90 degrees. So here we have 90 degrees would be straight up, 180 on the left-hand x-axis, and 270 down here. So if I sketch 254, here's 180, here's 270, 254 would be roughly right there. So this is 254 degrees. To find one positive coterminal angle. So you could go, if you went all the way around one time, that would be 360, and then to get to the same spot you would have to go an additional 254. So to find one positive we could go 360 degrees and then go another 254 degrees, and that would equal 614. There is not, remember, one correct answer, because I could go around twice. Once would be 360, again would be another 360, that would be 720, and then I could add 254. So there are an infinite number of positive coterminal angles with 254 depending on how many times you rotate fully around the circle and then come back 254. So to find the negative coterminal angle, this one we would want to go backwards. So if we went backwards, all the way around would be 360. So if you know that all the way around a circle is 360 degrees and this is 254, then to find the difference we would subtract it from 360. So you can either do 360 and subtract 254, and that gives you 106. But remember that you're going down first. You're going in a negative direction. So your answer would have to be negative 106 degrees. Or instead of worrying about the sign, you could do 254, and then from 254 you're going to back up and go all the way around the circle backwards. So then you would subtract 360, and that also will give you negative 106 degrees. Now just the same with positive, there are an infinite number of negative angles that would get you there. You could go all the way around once, that's negative 360, and then another negative 106. You could go in the negative direction twice, is negative 720, and then another negative 106. So there are an infinite number of negative coterminal angles also, depending on how many times you go around the circle. Number 38 is finding a reference angle. So again, first I'm going to sketch it. 390. If we go all the way around once, we were just talking about that, that's 360 degrees once. So how much further do I need to go to reach 390? And that would be I need to go another 30 degrees. So the reference angle, remember it has to be part of the bow tie, meaning that that angle has to go to the x-axis always. So what is the angle to the closest x-axis? It is 30 degrees. The final one that I chose, they give you a point and you need to graph it, and then use that to make an angle and to make a triangle to find the 6 trig functions. So first we're going to plot our point, 2, -5. 2 is the x, -5 is the y coordinate, that is right here. So we're going to make an angle that starts at the origin and goes to that point, right there. Now just like reference angles, these have to be part of the bow tie. They have to go to the x-axis. So when I make the third side of my triangle, it has to always go to the x-axis. So it's going to go like this. And there's your right angle right there. So if we label our two sides that we know that the length of the x is +2. And even though you can't have length be negative, since it's going in a since it's going down, it's going in a negative direction, we're going to label this side -5. So there we have two sides of a right triangle. If I want to find the 6 trig functions, I need all 3 sides. I need to find the length of the hypotenuse, and to do that we used Pythagorean theorem. So if these are A and B, make sure you use parentheses so you don't accidentally get -25. C is 29, or excuse me, the radical of 29. There are no perfect squares that go into 29. You can't simplify that. So we're going to leave that as the square root of 29 for our hypotenuse. And now, like we did in number 10 yesterday, it's a matter of plugging them in. So we have sine of theta, cosine of theta, tangent of theta, and after I find those, I will go back and do the reciprocal functions. Theta is always at the origin, so it's right there. There's your angle. Sine is opposite, -5 over hypotenuse, radical 29. And like I was saying, just like number 10 yesterday, we have to rationalize. So we have to multiply the top and the bottom by square root of 29. So -5 root 29 over 29. Cosine is adjacent. So adjacent next to our angle is 2. It's positive over root 29. And then again, we have to rationalize. And finally, tangent, opposite. So opposite's -5 over adjacent is 2. Now that you have those, we can fill in the reciprocal functions pretty quickly. So the reciprocal of sine is cosecant. Remember, don't use the one that we rationalized, go all the way back to the beginning. When I flip this, negative radical 29 over 5, that form is perfectly okay. You can have 5 on the bottom and a radical on the top, and you don't have to do anything with that. The reciprocal of cosine is secant. So again, we're going to go to the beginning, the very first one, and take the reciprocal, square root of 29 over 2. And finally, the reciprocal of tangent is cotangent, and you get -2 over 5.